Vrunda Agarwal wants to crash the PC today because I didn't respond to her email. No, I'm just kidding. I'm just kidding. Don't worry. Revenge, crash the PC. So between I met the students who crashed my PC last year. So I started recording the lecture. So, hey, but there are only 98 students. What happened to the other? Is the next class still going on, or what's the deal? DSM tutorial. Studying for medicine. Okay, I think I will start. All right. So let's get started. Okay, so in today's lecture, so we will look at bubble sort problem. We understand the algorithm for bubble sort, and we write code for it, and we see how things pan out. Okay, what's the problem? So in bubble sort, so let's say these are we have a list of elements such as this -1, 0, 20, 5, 10. And the problem is we want to sort this data. So we want to transform this data into a sorted list. Let's say we are interested in increasing order. So the increasing order would be -1, 0, 20, 5, 10. So we want to transform this list to this. No, this is wrong. No? So only Mitansh is awake. So increasing, so it will be, if it is increasing, it is -1, 0, 5, 10, 20. We want to transform this list. And the way we are going to transform this list into this list, into this sequence, which is an unsorted sequence, we want to transform this into this sorted sequence. And the way we are going to do is we do it in iterations. So in iteration 1, what we do is we compare. In bubble sort, what we do is we always put our finger on what we think is the largest element at this point in time. So initially we think we put our finger on the element -1, and we think -1 is the largest element. We compare -1 with 0. It so turns out that -1 is less than 0. So what we do is we move our finger to 0. Because now 0 is a bigger element when compared to -1. So what we did here is move finger. When we move the finger, the state of the list is not going to change. This is the state of the list. And after we move the finger, the state of the list is still the same, except that we move the finger. And then we compare 0 with 20. And again, when we compare 0 with 20, we figured out, 0, 20 is bigger element. So we move our finger to 20. The state of the list didn't change. So again, I use MF for move finger. Now we compare 20 with 5, and 20 is greater than 5. So what we do is we swap. So we swap. And then, so now our finger is on 20, element 20, which is the largest element. We want to bubble up the largest element towards the end. So that is why it's called as the bubble sort. Why? We are trying to bubble up the largest element towards the end. And now we compare 20 with 10. So again, what happens? 20 is greater than 10. So we swap. So either all the time our finger is on the largest element. In some cases, we just move the finger. In some cases, we swap and move the finger. So all the changes are happening adjacent. That's a good observation, sir. That's true. So now if you see the position of the element 20, it is fixed. Just follow my line of thinking and then I'll answer your questions. It is fixed. And we don't need to do anything with element 20. Now we focus our attention on this prefix list, which consists of the elements -1 till 10. So, how many iterations are involved here? If there are n elements, in order to bubble up the largest element towards the last position, how many comparison operators? Factorial n minus 1. You compare two adjacent elements, you keep on comparing. So n minus 1 operations. In iteration I1, there are n minus 1 operations. An operation here is a compare and operation with move finger, you swap or not. Okay. So you comparison definitely we do. So compare we do. And after compare, so there are two possibilities. Either there is a swap or there is a no swap. And then there is a move finger, because in any case we have to keep our finger all the time on the element which is the largest. So if the finger keeps moving to the right. Someone is not able to access the meeting. There is nothing I can do. Probably accessing incorrect meeting. So pasting the link here again. Hope this will help. Because I don't have, anyone can join anytime the meeting. So I'm not restricting anyone. Okay. So n minus 1 operation. So all these things, either you just compare, no, there are n elements and you compare one comparison, no, this is one comparison, this is two comparison. N iterations, roughly, let's count the number of comparisons. This is, I use a different color. This is one comparison, 2, this is 3, this is 4. There are 5 elements and 4 comparisons are there. So if you just count the comparisons, there are n minus 1 comparisons. Are you with me here? N elements, n minus 1 comparisons in the first iteration. Okay. So now let's yeah. So now what we want to do is, okay, I'll write this one close. N minus 1. And now iteration I2, we are starting here because since we don't have space, we are starting here. Minus 1, 0, 5, 10. The element 20 will be there, but we don't consider element 20 in the, because its position is fixed. So due to that, we don't consider element 20 and we put our finger on minus 1. We compare minus 1 with 0 and minus 1 is less than 0. So what happens? So we, it's just the same. The list will be the same. And we move the finger and the state of the list remains the same. It's not going to change. We compare 0 with 5 and again we just move finger because it's all good. 10 and then we compare 5 with 10 and so 5 and 10 it's the same, so we just move the finger and so we will stop here. So now how many comparisons are there in this I2? In iteration 2, if there are n minus 2, there are n minus 2 operations are present. N minus 2, n minus 1, 3 comparisons. And after that, so now when we go to iteration 3, so we have minus 1, 0, 5 and 10. The position of the elements 10 and 20, they are fixed. We don't do anything about it. And we repeat the same process here. So yeah, so if the suffix, the fag end of the array, of this array, it contains the elements in the position in the sorted array is fixed. For iteration k, so I have one more question for you. In order to make it slightly interesting, let's say for here instead of minus 1, I'm just changing the list in between. So in order to make it more interesting, let's say if it is equal to 6 instead of minus 1, then what will happen? Originally, if it is in 6, its position may change. I don't want to confuse you, but let's see. L. So let's say, hypothetically speaking, if it is 6, then in iteration 3, you compare 6 with the 0, and what happens? 0 will come here 6, and your finger will be on 6, and you compare 6 and 5, so you compare 6 and 5, again you do a swap, you get 0, 5, 6, 10, 20. So at the end of iteration 5, the positions for the elements 6, 10, 20 are fixed. Are you all with me here? How it is happening? We are bubbling up the largest element. We are bubbling up the largest element. So in other words, let's say if this is your original array, after iteration I1, what can we say about the list after iteration I1? That element here is the largest element. This element is the largest element. And we are doing n-1 comparisons here. And after iteration I2, so what happens is, these two elements. So what happens is in iteration I2, we work with only n-1 elements. So there are n-2 comparisons. So the largest two elements will be on the right hand side and they are in the sorted order. And after iteration I3, so we work on these n-3 elements and we pop and we bring the largest element here. Okay, so the large, so this is n-2. So overall, what happens is If you continue this process in iteration I1, this is the base case where you have all these elements are sorted, only the one element is left. At this point, we will stop. So if you look at the time complexity, the number of comparisons, if you add them up, this is n minus 1. If you add, it is n minus 1 plus n minus 2, plus n minus, this is n minus 3, guys. N minus 3 plus so on and so forth, 1. This is equal to how much? N minus 1 into n by 2. We are considering swapping operations, right? Is there a problem in Zoom, or are you all able to see the screen, right? Okay. So this is the total number of comparisons. And so we say n into n minus 1 by 2 is roughly proportional to n square. So why is that? If you take limit as n tends to infinity, what is n square divided by n into n minus 1 by 2? This is equal to 2. So as n tends to infinity, the difference between n square and actual n into n minus 1 by 2 is just some constant. If you take the ratio, we are just off by a factor of 2. And that is okay, because anyway constants are there, hidden constants are there, because we are counting comparisons, not worrying about swaps and so some other operations we are not, we are taking them easy. So this is all right. Okay, so we can roughly say bubble sort. So bubble sort requires approximately n square time. What is the sum part is we are just counting the number of comparisons. So from going to this state, we require n minus 1 comparisons. To bubble up the largest element, we need n minus 1 comparisons. And then to bubble up within this n minus 1 list, in order to bubble up the largest, we need n minus 2. I think it's okay. I mean, what I would say is, n minus 1, n minus 2, one iteration less, the count is not going to. Do you get the big picture? Why n minus 2? Like we have already seen here, why it is n minus 2. You see now here that minus 1, 0, how this is a list of 5 elements. How many comparisons we are doing? We are doing 4 comparisons in order to transform, to bubble up the largest element 20. To bubble up the largest element 20, to bubble up this largest element 20, we require 4 comparisons. Are you with me here that when there are n elements, why we require n minus 1 comparisons? Okay. And do you understand this time complexity analysis that to bubble up the largest element, and so we n minus 1, and then in the next step within this list we bubble up the largest element, we keep going on. Why did we divide by 2? When we sum up, what is the sum of first n natural numbers? N minus 1 plus n minus 2 plus, when we add all these things, this is nothing but 1 plus 2 plus 3 plus n minus 1, sum of first. And are you fine with this statement that we can roughly consider it as n square? So n square by 2, my point is we don't care about constants. Divide. Where are we dividing? No, this I want to show that, why and why we kind of take, this is the actual number of comparisons. I am saying this is an approximation and this is a reasonable approximation, because when we take the limit of these things, they are roughly grow in the same way. This is what is called as an asymptotic analysis. So as things, it is double, but it's a, I understand it's double, but if this growth is, usually the comparison is, so if we make the approximation as n cube, then what happens? If the approximation is n cube, then it's pretty bad, no? If the approximation is n cube by n into n minus 1 by 2, limit as n tends to infinity, then this is equal to n. As the value of n increases, it just diverges, no? It's pretty bad. This is not n, this is infinity, right? So, yeah, sorry. So it is, in that sense, it's a good approximation. This is infinity. Why did we? Okay. No, I think you will learn about this in the data structures course. But all I am saying is this is the number of actual comparisons is roughly this, and this grows approximately n square. Okay. And why I just tried to give a reason why it is the case, because when we compare these two numbers, at large numbers, it's, it's very, the difference between them is, this is, no, the ratio is some constant. In practice, for when we want to study algorithms in a mathematical fashion, we tend to ignore the constants. And because this constant, we can somehow try to manage it using some program optimization or use a more powerful processor, things like that. So we can kind of are you okay with my hand waving answer? So I want you to see, I want you to understand that n square by 2, it also doesn't make sense, because there are many other things that we are ignoring in the program analysis. And trying to factor them accurately, you will make a very mess out of it. And like, for example, why n square by 2, someone will ask, there is a comparison, and in some cases there is a swap, in some cases there is no swap, and there is a finger moving. So if you try to kind of put all those things into this, then what will happen? What will happen, guys? If you put in everything, or if you put in all the details together, what do you get? Are you able to hear me? Or I lost? If you put in everything together, what happens? All, no, like swap, no swap, moving finger, and there are other operations such as incrementing, no, the counter, loop counter, etc. So when we do all those things, you get a sambar out of it. Okay, and you cannot, if you get to eat sambar, what do you get? You will not be a khichdi or sambar. Yeah, khichdi or sambar. You will not be khichdi. At least you will be able to tell what all the ingredients are there. Sambar, you will not be able to make sense out of it. So So what are the things that are put in sambar? No, so no one knows, and you cannot make any kind of argument about sambar. It's, so we want to keep it simple. In order to make sambar simple, what do you do? In sambar consists of dal, it consists of tamarind, it consists of some water and some spices. Okay, so that's an approximation. Isn't it a good approximation for sambar? Like otherwise, so that's what I'm trying to say. When you try to make sambar, if you tell put every small detail you say, then we are going to just focus on eating. Not a bad idea. So okay then. So I think so that is my take. All I am trying to tell you is roughly when you are making sambar consists of these things, ignoring small nitty-gritty details. All right, so now let's come back here, and one thing I want you to note is when we are trying to move finger, let's go back to the original thing that we have here. If it is -105, when the list is already sorted, we put a finger here, we compare -1 with 0. -1 and 0 are the same, so you don't do anything. You just move the finger to 0. And 0 and you compare 0 with 5. 0 is less than 5. So you just move the finger to 5 and then the list ends there. If this is the case, can we say that the list is already, when there are no swaps, when there is only finger moving, can we safely say that the list is already sorted, that we don't need to go to the next iteration? Right? Yeah. So we can optimize the bubble sort program by whenever we find a list is already sorted, we just stop there. Okay. And this also brings to the question, hey, like for example, if you stop here, then in the analysis you are still counting it. Okay, let's say you stop somewhere here. So stop here because you figured out this part is already sorted, so stop. Already sorted, no swaps happened, only finger moving happened, you stop. Then no, in that particular case, then the number of comparisons that you took is actually less, right? But when we are doing this analysis, we are doing worst case analysis. What is the best case analysis for bubble sort? What is the best case for bubble sort? If it is already sorted, you just can. So if you keep changing your finger and you say, hey, it is already sorted, I don't need to do anything about it. Okay. So now, yeah. So what do we do now? So now what we try to do is we try to solve this problem, program it. Okay, so file save as okay, bubblesort.c. Okay, now so hash include So the way we are going to define the read array, so you tell me what I'm trying to do. Okay, this is the story. So the read array function, it will read the array, and what it will do is it will return the size of the array. So what does scanf function return usually? What does scanf function return? Can you do man scanf on your computer and see? Can you do a man scanf? Scanf function returns, if you see, the number of in the fields it has successfully read. Return value. If you see here, on success, these functions return the number of input items successfully matched and assigned. Okay, number of input. So the value end of file is returned if the end of input is reached before the first successful conversion or a matching failure occurs. Okay, is returned if the end of input is reached. Okay, so what happens is the scanf function. Did you ever read man pages? You should read man pages. Okay, the scanf function returns the number of inputs read. So let's compile this program and see what happens. Okay, quit GCC bubblesort.c dot a.out, and this is cd CP21B GCC bubblesort.c. Yeah, so 10, 20, 30. What is happening here? So now I entered 10, 20, and 30. So now what happens? What happens here is Where will 10 be read into? So just try to understand this. So if size of plus plus, this expression, if size, we don't need GDB here. If size is equal to 0, what will size plus plus return in the first iteration of the while loop? 0. This is post increment operator. Okay, so the value 10 will be read into A of 0. So 10 will be read into A of 0 because size is equal to 0. And what will be the return value of the scanf statement? What is the return value of the scanf statement? It is 1. The number of input fields it has successfully read. So 1 is not equal to end of file. So you go back again. Next, what happens? What is the value of size when you go back in the while loop again? So it is equal to 1. So 20 will be read into A of 1. End of file is a special symbol. Okay, it is defined in a special way. Don't worry about it. So 20. So now what is the scanf return value? Scanf return value is not 2, it is 1. Scanf returns the number of fields it has successfully read. So now it read 20. Now after that 30. So 30 will be read to A of 2. And then after that I pressed Control D. When Control D is pressed, indicating this is a kind of end of file thing, then what happens is this doesn't match. So this doesn't match %D, end of input is returned. So what happens is, in this case, scanf returns end of file symbol. So when we press Control D, when the end of file symbol, what scanf does is it just returns end of file and we come out of the loop. Are you with me here? When we come out of the loop, when we come out after 10, 20, 30, you just press Control D or give any input which doesn't match the integer. Then what happens is scanf will come out saying, it's, hey, I'm not able to read, scan any more integers from the input stream. So it comes, it returns back with a, no, just think of end of file as a special symbol, okay? Think of end of file as a special symbol. So anyway, so I want you to don't get bogged down by it. You can just take this code as a template to read inputs when you don't know the size of the input. Okay, and later on figure out for yourselves what it means is. Hey, this is homework, okay? I don't want to spend more time on this. Decipher this loop. Homework. Will you be able to dissect this loop and understand what happens? Can you do that as a homework? Small loop. Can you read the man page? Can you read King book? Can you do whatever you want to read? Can you understand 9 as a homework? You should try it, because I want to make this distinction between logic versus language. And C language has some peculiarities, and all this end of file business, it's the language peculiarity. Just like in Hindi, or in Hindi or Telugu, whatever that, the gender, verb, gender thing, it's very peculiar thing. In many, every language has its own peculiarities, right? So you can just read it in the man page, you can read it in Essential C, what happens, why this thing works. All right, I think some of you may be unhappy, but the point I want to make here is, simpler explanation is scanf returns the number of fields it has successfully read. When it encounters 10, it reads 10 and assigns it to A of 0, returns 1. Same with 20. assigns it to a of 1, assigns 30 to a of 2, returns 1 in all the cases. But after that, if you press Control D or any character which doesn't match with %D field, then it returns an end of file symbol. Think of it as end of file is some special symbol. And when it returns end of file, you just come out of the loop. And when you come out of the loop, you are returning the size. My question for you is the return value of the read array, is it the right return value? Space is not taken as a different character. No, space. So what should we return here? And if you see the here, let's say, yeah, you can see when you print na, you are printing 10, 20, 30, 0, because we are returning the size of this array as 4. So instead we should be returning size -1. Because we have incremented size ++ here in anticipation that we may end up going in the while loop, but when we don't go through the while loop, then no, we have to change our mind on the size of the array. Are you all with me here on line number 11? So after, let's see. Yeah, let me maybe. See, what I'm trying to tell here is on in this loop, when you enter the while loop, so this is iteration I0, when you enter while loop, size is equal to 0. Okay. And then after you read 10 into a of 0, size has become equal to 1. So in iteration 1, when you start iteration 1, size is equal to 1. So you read 20 into a of 1. And then because of the ++ operator, size has become equal to 2. In an iteration I2, so size is equal to 2, and you read 30 into a of 2. And then what happens? Size is equal to, has become equal to 3. Okay. Yes or no? Yeah. And then what happens in iteration I3? So size is equal to 3. And yeah, so we have size is equal to 3. And there are different ways of doing it, but size is equal to 3. And what happens is size becomes equal to 4 because of the size ++ operator. Okay. And so we are returning the size of the array as 4. But in fact, the size of the array is 3. Does this make sense? Kind of. Maybe I want you to think about it, guys. Okay. So so by this time, these no small nuances you should be able to catch quickly. Okay. So I will proceed. Okay, so now what we want to do is, yeah, it returned the 0 because the array value, it could be a garbage value also. If the loop breaks, Muskan, so size ++ gets incremented. No, that's not the increment of the previous loop. ++ operator. Are you guys reading the textbook at all? How many of you are reading? any textbook, no? Because size plus size, these are very, all the time they are meant to reduce the size of the code, but they cause more confusion. Syntactic sugar, they cause more confusion than any advantage. Size plus will happen during this also, Anusha. So the way it happens, I want to make it clear one more time. I think there's quite a bit of confusion here. In this scanf, there is something here, right? So what happens is, if size is equal to 3, then before the scanf gets executed, so before the scanf gets executed, you use 3. The size, the return value of size will be used, and then it's incremented, and after that scanf happens. I'm lost. So yeah, so what is yeah, I think what I want to do is let's I just want to put it this way. So this code that you are seeing here, it's not no, there is no equivalent code. Anyway, I think I'll leave it here. I think the logic is very, very simple. It's the only one important thing I want to point out here. There are 3 things that are happening here. One is evaluation of this expression, this size plus whatever the value of size that is present here. Okay. So approximately what Abhinav pointed, that's what happens there. And no, that's wrong actually. And then after that, so let's say size is equal to 3. This value of 3 will be used here. And then size is equal to size plus 1. And then in the third statement, you do the scanf. These are the 3 things that happen. This is the semantics. Are you with me here? Like, does this make sense? Let's say the value of size is equal to 3. That is the return value of this expression. That 3 will be used here. The 3 will be used. The return value of the expression will be. And then there's a side effect for this expression. The side effect is size will be incremented. And after that, the scanf will be executed. Yeah, I understood. Shall we move on? Sardak, my man. Okay. Okay, let's move on. I want you to understand 9 by yourselves. And so, yeah, in the other class also, there are lots of problems in this code. Not problems, it's simple only. But for some reason, I'm getting a feeling you guys are not reading the book sufficiently. So, yeah, int size we are going to program bubble sorter. Thanks for reminding. So let's say this is enter array size. Okay. Scanf. This is an alternate way of reading the input. And for int I is equal to 0, I less than size, plus I, scanf, %d. Are you happy with this code? Return size. Okay. This one you're all happy, na? This one you're all happy. You can even print it, no? Give a prompt also. So if you compile this code, gcc bubble sort .c 4, 10, 20, 30, 40, all good. So, but do you prefer the previous version of the code or this version of the code? Why do you prefer the previous one? Compact. There is one primary difference between the previous version and this version. Yeah, when we don't have the size, then no, here we need to know the size of the array, but okay, so now stdlib. Do we have a class at 2 o'clock today? Somehow. Shall I think I may overrun by a few minutes, 10 minutes. Is it okay? I want to finish the bubble sort code. So now here, if you see array yeah, so in the 300, so it says can't handle that big a list. Okay, so do you see the exit function here on line number 15, that when things are not, if the array size is too big, you just quit at the very beginning and come out. Okay. So now we want to write code for bubble sort. It can be other values also, it need not be. Do man. So this is the code for. What if you want to give a second chance for int I is equal to 0, I less than size, plus I, if a of I is less than a of I plus 1, you don't do anything. Continue means what will continue do? Otherwise you swap. Continue takes you to the beginning of the loop. Okay. What do you think this program, this code will do? Terminates the current iteration. Yeah, terminates. You go to the, it will, now if you run this program, can you give me some example input? A dot out, let's say the array size is -1, 20, 5, 10. What happened here? What happened? Nothing is happening. Why nothing is happening? Not even that. We didn't call the bubble sort function. Bubble sort A size. Okay, so now you can see that in this particular case, interestingly, the list is sorted. So does it mean our algorithm is right? Can you give me a counter example for this where this doesn't work? Can you give me a counter input example? -1, 20, 10, 5. -1, 20, 10, 5. Yeah, great, awesome. So now you can see that we are running only one iteration of the loop. Because of that, we are able to only get the maximum element. Are you all with me here? That since we are running only one iteration of the loop, we are only getting one maximum element. So we have to continue. So those of you who are wondering how we can use, can we say bubble sort A size -1 now? Do you think this will work? We just have to sort the prefix, right? Do you think this will work? It's very simple. Now you recurse. Use recursion. There is only one catch though. If you run this program, what happens? Your program crashes because there is no base case. What is the base case here? What is the base case? If size equal to 1, you don't do anything, you return. So this is the base case. See, you are all hating or crying against recursion. Because of recursion, just one statement on line number 69 and one base case, then that's it, the sorting is done. Or do you understand what is happening? We just added a statement on line number 69 and a base case on line number 52, 53. That's it. The story over. That's all. You are all done. So now you will see bubble sort.c. So give me some example input, guys. A dot out 4. Okay. 10, 40, 30, 5. Awesome. Good enough. So that's all. So how easy to write the sorting? I want to see the power of recursion here. Before we optimize, I want to see line number 69. So all we did is, so here, this is the list. And using this loop, we bubble up the largest element to here. Using this loop, we bubble up the largest element and then we recurse. Don't worry about memory and all. Actually, it doesn't require more memory in this case, but it's And let's try to optimize this code a bit. Okay. So now we want to say we will use swap underscore count is equal to 0 whenever there is a swap underscore count plus plus. And when do we call this one? If swap underscore count is equal to 0, if it is greater than 0, then only we will recurse. Otherwise, it's already sorted. Does this make sense? If all we are doing is finger pointing, then it is already sorted. So we are done. Optimization done. Replace a comma after temp. Where is that? Oh, okay. I see. See, same. So shall we write a loop version? How do we write a loop version of this code? Hey, something happened. There is a bug. It's not working. Enter 10.4. What's the bug here? After we did that swap count, something is not working. 4, 10, 40, 30, 5. No, size minus. Now it worked. Maybe I pressed something weird. 10, 40, 30, 5. 4, 10, 40, 30, 5. I don't know why it gave a weird answer up there, but otherwise it's now looking good. Maybe I pressed some weird key. Okay. Are you all with me here on this code? How do you write a loop version of the code I will take? Not on the swap, think about it. How do we write a loop version of this code? Loop underscore bubble sort. We will replace this while size greater than 1. We want to continue to iterate until size is greater than 1. Format document. Do you understand this code? While size is greater than 1, we do this thing. So finally, we do size is equal to size minus 1. Does this work? Lunchtime, huh? Okay. Is this okay? Is this loop version okay? How we change the recursive version to the loop version? And how do we handle the swap count here? I want you to think here, if swap underscore count is greater than 0, home, you want to repeat again. Does the code from 98 to 104 make sense? So I will stop here. Actually, I will not explain, and I want you to look at the code and understand. I want you to think about it. No, like there is fun in going through the code by yourselves and trying to understand whether it makes sense or not. Can you do that? I want you to do it. Okay. So I will stop today's lecture here. It is 1:15. I think you're all hungry.